Okay, in this video, we're reviewing the warm-up number 1, our quiz prep. It's going to go through solution vocab, molarity problems, and dilution. So it has 16 questions, going to be worth 25 points, and you'll have 45 minutes to complete it on Linkit. We'll have 7 on solution properties, 5 on molarity, and 4 on dilutions. So our first one says label each bottle as a colloid C, solution S, or a suspension SU. Hint, there's one of each. If you're using our virtual one, you can double click so you can add it to the lines right here. So what we're seeing is the Tyndall effect. And what it says that if you have a colloid or suspension, when you shine light through it, it will scatter and create a beam. So if we take a look at our 4 jars, we shine our light through. Nothing happens in the first one. So if nothing happens, that's going to represent our solution. There's no particles because they're so small that will reflect the light as it goes through it. Now we see scattering and a beam in the second one in B, so that could either be a colloid or suspension. Now the big hint of C is that there are large particles, so we have to ask ourselves which one has larger particles, our colloid or our suspension. And we'll see that our suspension has larger particles, so that's going to be C, and then that means B would be our cloudy colloid with its medium particles there. So that takes us through a few different concepts, our Tyndall effect, and then our particle size for our solution or homogeneous mixture, our colloid cloudy mixture, and our suspension, which eventually those particles can settle out to the bottom here. So, based on your notes, decide which category the following examples would best fit in as a suspension S, colloid C, heterogeneous HE, or homogeneous HO. So, our mixture is left to stand out a while and the particles settle out to the bottom. So, because they're settling out to the bottom, that means they have larger particles. So, if they have larger particles, it could be a suspension or heterogeneous. For this one, we're going to choose S for suspension. Now, this could be like if we had sandy water, like we saw in class, that those big particles of sand would settle out to the bottom. Letter B, the mixture is clear and transparent. And we saw this in the last one there with our Tyndall effect. We see this would be HO, also known as a solution, which is a synonym for it. And our example was salt water in class, and we saw that no beam scattered it, and it looks uniform throughout from the top to the bottom. Letter C, a beam of light is passed through and the light scatters. So the options could be a colloid or a suspension. Now, it doesn't mention anything about particle size, and we've already used suspension, so this is going to be our C for colloid, and we'll see that it also could be cloudy. We talked about the example as milk in water would scatter that light, or fog, or even if we put shaving cream in water, anything that would cause it to be cloudy. So a mixture is poured through a filter, and the pieces of the mixture do not pass through. So if we see that we have our filter, that's our physical means, and when we talked about filtering in class, that would be HE for it. Now, we could also say because they didn't pass through, they had large particle size as our suspension too, but we've already used that option because remember, we're looking for the one that best fits the description for it. Okay, now we're ready for the math, so you might want to grab your calculator right now. Seawater contains roughly 0.23 moles. It's a math part. I'm going to circle it per 0.55 liters. What is the molarity, big M, of sodium chloride in seawater? So I don't know my big M. I know my moles is 0.23 and my liters is 0.55. So I'm going to have 0.23 here and 0.55 here. So when we put it in our calculator, we're going to see that we need to put 0.23 in first and then 0.55 in second. And we get a very long decimal, 4181818 repeating. So we'll see that 0.2 has 2 sig figs, 0.55 has 2 sig figs, so we'll count over 1, 2, will 8 round it up? Yes, it will, so 0.42 molar for our first one. Now our second one on molarity says how many moles, so that's something I don't know. Are there in 10 liters? That's going to be my volume of my solute, and 2.0 big M, that's going to be my molarity. So this time I know my molarity, I don't know my moles, and I have 10.0 liters. So I'm going to put my X with my moles, and then my 10.0 with my liters, and my 2 with my molarity. Now I can put a 1 here to help me visualize. To solve for this, I can cross multiply. So X times 1 is X, and then 10 times 10.0 times 2.00 gives us 20. Now, if we're looking at sig figs, this has 3 sig figs, this has 3 sig figs, so I would just see as an answer choice 20.0. Now, its unit is what goes with X, so we would have 20 moles in this sample of Na2CO3. So our final one is on dilutions for this warm-up. How many milliliters will you need of a stock solution of 5 molar to dilute it to 1.5 molar with a volume of 125. So if I take a look, I'm looking for how many milliliters of my stock of 5 molar. So those two are tied together. That gives me my 1 and my 1. Then I have 1.5 molar of 125. That gives me my 2 and my 2. So we can start filling it in here. We're going to have 5.0 molar. We don't know the volume. We see we want to dilute it to 1.5 molar, and I want to have 125 milliliters of that dilution. So our dilution equation is M1V1 equals M2V2. So I'm going to put my 5 here, my X, my 1.5, and my 125. So now I'm ready to solve it. 5 times X is 5X, and then we're going to do 1.5 times 125, we get 187.5. How do we get X by itself? We're going to divide both sides by 5. So X is going to be equal to 187.5 divided by 5, and we get 37.5. Now, if we look at our sig figs, we're going to have 2 sig figs here, 3 sig figs here, and 2 sig figs here. So I'll count over 1, 2, and we would see that we would have 38 milliliters. Now, the secondary question is, how much water would you need to dilute it? So if we think about our beaker, we're trying to make a dilution of 1.5 and 125 milliliters. So I need 125 milliliters as my total. You just figured out that there are 38 milliliters of my stock, aka that concentrated 5 molar. So what would fill in the space here to get it to that dilution? So remember, if we're diluting, we have to add water. And how we find out how much water, we're going to do 125 minus 38. And that's going to tell us how much water we need. So we would need 87 milliliters of water to perform this dilution. So this video just took us through our warm-up on solution properties, molarity, and dilution. Thanks for watching.